All right, welcome back. I went through my other tutorial of how to find a limit, how to use the definition limits and how to find a limit using algebra, not using algebra, using numerically, using a table, and also graphically. I'm going to do the same thing with another example. What I have here is I have a limit, all right, where it's going to be x over the square root of x plus 1, minus 1. And in order to find a limit, once again, a limit by definition is a value you are intending to reach, or is the output that you're intending to reach as x approaches 0 from the left side, all right, and as you approach, in this case, 0 from the right side. Okay. Now to do this, we're going to do this numerically first. So I'm going to take, in order to find this limit, I'm going to plug in values into a calculator. Now I already did this for you, so if you take your calculator out and you start by taking and punching this into your y equals, and then you, if you want to follow along at home, all right, you can start plugging in values that get closer to c. Now this is the c value that we're referring to. The c value is the x value that we're getting infinitely close to. Okay. Now in this case, it's going to be 0. Now to find the limit, we're going to take the limit as x approaches, all right, c, or 0, to the left. So to the left means I'm going to plug in values that are really close to 0 to the left. That would be like, for example, negative 0.01. So if you take negative 0.01 and you plug that in there, it's going to be 1.994987. Well, you can probably guess where it appears where this is going to. It appears as this might be approaching 2. Well, just to make sure, I'm going to get closer to that. And if you plugged in negative 0.001, you would see that this value gets closer to the 1.995. And as you continue on and you plug in negative 0.0001, you realize this is 1.9995. And it appears, I think, once again, that this value is approaching 2. And we can see that. Now, if you actually plug in 0, and this is what makes this kind of strange, is when you actually plug in 0, you actually get an error or no value at all. Okay, and that's what we have here. So we have 0, there's no value. All right, so this actually is at 0, it's undefined. Okay, but yet there is a limit that appears as you approach 0 from the left is going to 2. Now doing the same thing, or similar thing, we're going to take the limit as of f of x, so this function right here. Okay, we're going to say this is f of x, just so everybody knows. All right, and now we're going to approach 0 from the right side, because they have to approach the same value from the right and left side. So as I get closer, all right, I'm going to change the other side. And as we get closer to 0 to the right side, I'm going to put in 0.01. And you notice it's 2.004988. Well, that also appears approaching 2. We have 2.005 as we get closer to 0. And as we continue to get closer, we realize it's going to be 2.0005. And yes, I think we can confirm that this value to the right of 0 is also approaching 2. Now, because they're approaching the same value from the right and left side, the intended height, or the f of x value that it's approaching, appears to be approaching a single number 2. And that's single number 2, and that is our L. That is our limit. Okay? Now, with that, we're going to now find the limit using it graphically. Now, to find this limit graphically, we're going to be taking this, all right, and looking at the graph. You can see, all right, we have, appears to be like a square root function. And we're going to be approaching this value from the right and left side of this graph. And if I take this, I'm going to try to blow it up even more so we can really see where this is going. All right. So as I have this, we're going to be approaching this value, all right, at 0. Okay, at 0. So as we approach 0, all right, from the left side, so this is x approaching 0 from the left, we visualize and we can see that it appears my outputs are approaching 2. It appears it's approaching 2. 1, 2, yeah, it's going to 2. As you approach x as approaches 0 from the right, it appears, all right, I'm going to use a different color, as we get closer and closer to this way, it appears that our value is approaching, once again, 2. All right, our value is approaching 2. Now, because we're approaching the same value to the right and left side of 0, and that value is 2, we can now visualize and see this graphically that, yes, our limit is 2. Two different ways of finding a limit, all right, both applying the definition of limit, because a limit is an intended height of a function. It's a value that you're approaching from the right and left side of a c value. Remember, this is our c, all right, and the value you're approaching, which is an output, all right, that is what your limit's going to be. All right, so I hope this helps you out, and hopefully identifying and finding some other problems that are related to limits.